Yes, this is a problem from expansion of solids. So here in this case, what is given? Let us see. A solid sphere of radius r mass m is spinning about a diameter as axis with a speed omega naught. Okay. Now the temperature of the sphere increased by 100 degrees centigrade without any disturbance. Yes, it means that without any torque. If coefficient of linear expansion of the material of sphere is 2 into 10 power minus 4 per degree centigrade, the ratio of angular speed at 100 degree centigrade, okay, and omega naught is, yes. So let us see what is the given data. Okay, here given initial angular velocity is how much? Omega naught. So omega 1 equal to omega naught. Next, temperature is increased by 100 degree centigrade. Delta T is equal to 100 degree centigrade. Okay. So without any disturbance means what here? So net torque equal to what? 0. And coefficient of linear expansion alpha is given. Alpha is equal to 2 into 10 power minus 4 per degree centigrade. That is given to us. Okay. The ratio of angular speed at 100 degree centigrade and omega naught. So which means here they are expecting omega 2 by omega 1. Okay. So this is required here indirectly. Of course, omega 1 is equal to what? Omega naught. Now for this one, what we can do? Simply we can apply conservation of angular momentum. Why? Net torque is equal to 0. Net torque equal to 0. Therefore, angular momentum equal to constant, which indicates here I1 omega 1 is equal to I2 omega 2. Okay. Now, I1 is as it is, omega 1 is how much? Omega naught. I2, yes, from the concept, I2 is equal to I1 into 1 plus 2 alpha delta t, and omega 2 is as it is here. Okay. Now I1 gets cancelled here. Okay. Now we require here omega 2 by omega 1, which indicates here omega 2 by omega naught is equal to here 1 by 1 plus 2 alpha delta t. Yes. So therefore 1 by 1 plus 2 into alpha value is how much? 2 into 10 power minus 4. Delta t is 100. Okay. So as a next step here 1 by 1 plus 2 into 2 4. 4 and here 10 power minus 2. 4 into 10 power minus 2. That equal to here 1 by, this is a 1 plus 0.04, which indicates here 1 by 1.04. So this is the answer here. Okay. So we can say answer is second option. So this is the answer for the given question. Now the next question is, a wire of length L0 is supplied to heat to rise its temperature by T. If gamma is coefficient of volume expansion of the wire and Y is the Young's modulus of the wire, then energy density is. So energy density means here U dash. So here U dash equal to, we know, half into Y into stress into strain. That only we can write here half into Y into strain whole square. This is from theory. Okay. So therefore here half into Y into strain. Change in length by initial length here. So therefore delta L by L whole square. Okay. That equal to half into Y into delta L by L. Yes. Or delta L is equal to what? Alpha into delta T into L. By here L is as it is. So this is a whole square. Okay. Now here L gets cancelled. As a next step here half into, okay, Y alpha square and here delta T square. Delta T is given as what here? T. Okay. So because rise in temperature is T. So this is a T square. Okay. But options are given in terms of gamma. We know this gamma equal to 3 alpha. Therefore alpha is equal to how much? Gamma by 3. Okay, so as a next step here, half into y into, so this is a gamma by 3 whole square into t square, that equal to here half into y here gamma square by 9 t square, that is equal to here 1 by 18 y gamma square t square. Okay, so what is the answer? Which option here? Option is yes, this is D is correct here. So 1 by 18 is there here, y is t square gamma square. So this is the answer here. Okay. Now the next question. So in this question, a uniform solid brass cylinder of mass m equal to 0.5 kg and radius 0.03 meters is placed in a frictionless bearings and set to rotate about its geometrical axis with angular velocity 60 radian per second. After the cylinder has reached the specific state of rotation, it is heated without any mechanical contact. Yes, from the room temperature from 20 degrees centigrade to 100 degrees centigrade. The fractional change in angular velocity in the cylinder is, and here alpha is also given like this. Okay, so here without any mechanical contact, so net torque equal to 0 because of net force equal to 0. Since net torque equal to 0, we can apply conservation of angular momentum. Okay, so from the theory, so very simple here. So from the theory, we have the formula delta omega by omega equal to minus 2 alpha into delta t. How we are getting here? This is by applying law of conservation of angular momentum plus moment of inertia concept. So this is the formula from the theory here. Okay, and here if you observe here the fractional change in the angular velocity of the cylinder. Yes, now it means delta omega by omega. This is a minus 2 into alpha value is what? 2 into 10 power minus 5 delta t. Delta t is how much here? 100 minus here 100 minus 20. That equal to of course 80. This is a minus 4 into 10 power minus 5 into here 80. Okay, so this becomes here minus 320 into 10 power minus 5. That equal to here minus 3.2 into 10 power minus 3. Okay, so this is the fractional change in angular velocity of the cylinder. Yes, so if you observe the options here A, B, C, D, so which option is suitable? Answer is A. Yes, so finally this is the answer.